This is video 6B of our plant diseases course. And in this video, we're going to take a look at two more sets of abiotic disease, weather and herbicide injury. We know weather can wreak havoc with plants because we've seen it. Sometimes we lose a crop of lettuce or tomatoes due to hail. And sometimes there are longer lasting effects depending on the plant and the weather event. When temperatures turn cold, we find that internal plant temperatures drop below their resistance, and this makes the cellular contents freeze and then expand. Ice crystals form, and those crystals are sharp and so puncture the cells. When temperatures warm up, the cell contents drain out, the cells die, and we get necrotic tissue developing. And then you see plant damage similar to the arborvitae in this picture. Evergreens with freeze injury can have various symptoms, but most often you'll notice brown or chlorotic needles. Look at the pine in the far right photo. The needles weren't hardened off when early fall sub-zero temperatures arrived. The tissues froze, and then you can see the resulting leaf scorch appearance. Remember, when plant tissue freezes, it's actually being dehydrated. So it's not surprising that symptoms of leaf scorch and leaf freezing might look pretty similar. Notice that a similar tree just behind that pine shows little damage in comparison. It could have come from a different, hardier source than the tree in the foreground. The pine in the middle looks more chlorotic than brown, but it's still the result of early sub-zero fall temperatures. The spruce on the left had just formed new growth in the spring. Cold weather arrived and killed the newly developing shoots, and now they look wilted and dried out. Here's some freeze injury on deciduous plants. You've probably seen the necrotic, wilted-looking tissue like in the left photo. The aspen leaves in the middle picture not only have necrotic areas, but those necrotic areas are also distorted too. The heart-shaped look of the aspen leaf on the far right was because just that part of the leaf that's necrotic was sticking out of the bud when the cold event arrived. Spring freeze injury can damage portions of plants just as you saw in the aspen, but freezes can also kill all the newly developed leaves, like you see on the ash. So now the plant has to releaf, which takes energy and can be a drain on the tree, since it's also at its lowest stored carbohydrate reserves at this time of year. In the right picture, only the tips of the daylily leaves are frozen. The leaves closest to the ground are still green, and they've been kept warmer by the heat radiating from the soil. By summer, more leaves will fill out the plant, and you won't even know this happened. On the opposite end of the spectrum, warm or hot temperatures can also damage plants. In this example, the pepper fruit on the left was exposed to intense sunlight during hot weather. This usually happens because the leaf cover is thin or the fruit grows beyond the canopy. Shading plants can often help decrease the problem, and you can see an example of the shade structure in the photo on the right. Flower stalk formation, or bolting, appears on many cool season vegetables when temperatures begin to warm in early summer. The process can't be reversed, although shading the crop to keep temperatures cooler may delay bolting just a bit. So how can we manage plant problems related to temperatures? First, find out the plant's requirements and put it in the correct location. As an example, this hosta is growing in a site that's too hot. That's why the leaves are scorching. But originally, a tree had provided shade for it, and it didn't scorch. The tree broke up in a storm, had to be removed. So now the hosta is scorching as a result. So either a new tree should be planted to provide some shade, or the hosta should be replanted in a cooler location. These pictures show drought symptoms on both a juniper on the left and a catalpa on the right. What symptoms do the two plants have in common? The necrosis or death is from the top down, which is the opposite, if you think about it, of oxygen starvation. Think of the tree's conductive system acting like sucking water through a straw. The hardest place to suck the water is to the top and the branch tips, and that's where the symptoms will show first. The catalpa is actually suffering from transplant failure or failure to root, but the symptom is that of drought. Think about it. No roots, no water, and that equals drought and death. But a caution, always examine plants and the surrounding soil carefully before concluding a plant is suffering from drought. Sometimes oxygen starvation can cause drought-type symptoms, and applying more water will just make the situation worse. Sometimes we find necrotic tissue on junipers as the result of insect infestation, voles chewing on the lower parts of branches, and overwatering. And that's just to name a few. Now let's turn our attention to herbicide injury. Herbicide injury is just one of many chemical injuries that can happen in the landscape. Herbicides are products that are applied to kill weeds. The symptoms are varied and can easily be confused with other abiotic disorders or some biotic diseases. Any type of chemical injury can happen locally with carelessness by the user, but it's not always the case. Some products drift, that is, move from the area that they're intended to be applied, and they move to an unintended area in the air. Some products can be passed through animals in their manure or found as residue on straw that is used as garden mulch. There can be enough product in the straw or manure to cause plant damage, similar to what you see on the left. One of the symptoms of herbicide injury can be a loss of chlorophyll, the green pigment in plants. Some gardeners mistake this for iron chlorosis, but it's not. All three of the plants on your screen were injured by different herbicides that killed plants by inhibiting or interfering with the production of chlorophyll. And if you think about it, it makes sense. If a plant can't make chlorophyll, it's going to die. Another symptom of herbicide injury is distortion. Although caused by herbicide, the plant on the right picture has symptoms that are consistent with a certain type of mite feeding, which is a biotic problem. And you've already seen powdery mildew and freeze cause distortion in plants. So the question becomes, how can we manage this or prevent it in the first place? Well, first of all, we always read the label directions of a product and use it according to the directions. We also need to be aware of the symptoms. Another thing you can do is if you use manure and straw in your garden, check with your sources to see if herbicides have been used or if animals have fed on herbicide-treated plants. Whether or not a plant will suffer permanent damage is going to depend on the plant, the amount of product reaching the plant, and the environmental conditions. Although this module was a quick tour of some common abiotic-caused plant problems, I hope you've seen just how important they are to cover in the plant disease topic, and that many symptoms mimic each other. In our face-to-face class, we're going to look at both abiotic and biotic disease symptoms and discuss them together. This is the end of the videos for the plant diseases course.